All right, 4.4, modeling with formulae. When we're working with formulae, what happens is that oftentimes, for example, in science, you're asked to actually isolate for a variable before you actually plug in numbers for the letters. So, for example, we're going to look at some examples here, such as isolate for the specific variable indicated. So we have d equals a plus b, isolate for b, c equals 2 pi r, isolate for r, a is equal to L squared, isolate for L. D is y equals mx plus b, isolate for m. Then you're going to try and isolate for x, and you're going to try and isolate for b. And finally, E is d is equal to speed times time. We're going to isolate for time. Now, folks, these are just any old formulas that are just given to you. These formulas actually come from formulas you've been exposed to from before. For example, d equals a plus b. What that means is, given a triangle, for example, a triangle like this, the exterior angle, let's call it d, is equal to the sum of the two angles on the inside but not connected to that exterior angle. That is this angle, which would be a, and this angle, which is b. So this is a plus b is equal to d. That's where this formula came from. Now let's say you knew the values of d and a. How would you find this angle b? So that's what you're asked for when you isolate for a specific variable. So we're isolating for b. B is going to equal, now we're going to leave the b on this side, on the right side, because it's already positive, and we're going to move the a over. That is, d minus a is equal to b. That, folks, is how you isolate for a variable. Treat the other letters like numbers, like they have to move over. The variable you want, such as in this case, b, we want b, we leave b alone. So if you want, what you could have done was made b another color and said, okay, I need to isolate for that letter b. And that's what we did. We kept b where it was and moved everything else over. So let's look at the next example. Part B. Where did this formula c equals 2 pi r come from? Well, you should remember it from a circle. That is, from a circumference of a circle. This formula is the formula for the circumference of a circle. Sometimes you'll be given the actual circumference, and you have to figure out what the radius is. Well, that is, what you have to do is take r and take r by itself. In order to keep r where it is, r stays here, we need to get rid of this 2 pi. This 2 pi is being multiplied by r. That is, we can move it over by saying c divided by 2 pi. To move the 2 pi over, we have to divide both sides by 2 pi. So c over 2 pi is equal to the radius. So if you know the circumference, you can figure out the radius of any circle. Let's look at the next one. A equals L squared. Where have you seen a formula like this? Hopefully you're remembering a square. That's right, a square. If I know the length of one side, let's call it L. The area of that square is equal to L squared. So we need to isolate for L. Let's say I know what the area is. What is the length of the square? Well, to do that, we need to get rid of this square. How do you get rid of a square in a formula like A equals L squared? Well, folks, that is, we take the square root. That's right, we move the square over by taking the square root. The square root of what? Well, the square root of A. L, the length formula, the length is equal to the square root of the area of a square. Okay, let's look at another example. This formula here, right here in D, you're going to see a lot of in grade 9. We're introducing this formula to you in grade 9. In grade 10, 11, and 12, it's used quite extensively. And the assumption is you know what this formula is. This formula we call it the equation of a line. Now, we're going to learn about this equation of a line later on in grade 9. But right now, all you have to do is look at this formula and say, okay, I need to isolate. What do I need to isolate for? Well, let's isolate for m. That is, get m by itself. The easiest one is to do b, so let's do b first, folks, just to do b. Make b by itself. B is here. We want to move it over so that it will become y minus mx. That's right, b is equal to y minus mx. So b is now done. Let's isolate for x. To isolate for x, what we need to do is get x by itself. To do that, we need to move the b over first. So we're going to get mx by itself first, and that means that mx is equal to y minus b. That's right, move the plus b over, it becomes minus b, so we have y minus b. Once we do that, we can now divide both sides by m. We divide both sides by m, we get x on the one side, and y minus b gets divided by m. Oops, that's a lot, folks. Let's go backwards a little bit. Just a little bit here, okay? So we have y minus b over m is equal to x. And now we have solved for x. Okay, now we're going to isolate for m. So again, the same thing that we did for x, we can do this first. So we have y minus b is equal to mx. But this time, isolate for m. That is, we divide both sides by x. M is equal to y minus b over x. And what we've now done, folks, is we have isolated for x, b, and m. We've isolated for all of those from the original formula, y equals mx plus b, which is the equation of a line. All right, the last one. Distance is equal to speed times time. This formula is used quite extensively, especially in physics and in science in general. And you may have learned this with a formula with a triangle, and that is the DST triangle. So that if at any point I wanted to calculate, let's say, distance, I would cover up the d, and it would mean that speed times time. If I wanted to calculate speed, I would cover up speed just like I'm doing here, and I would get distance over time. If I wanted to cover t up to find time, I would do distance over speed. Now that's the easy way to do it with this formula. How do you do it when you actually have a formula? So, for example, d is equal to speed times time. I need to isolate for time, get time by itself. That is, time is equal to d over speed. That's right, folks, d over speed. All right, folks, well, that's the end of the lesson. You can try some examples in your homework. Have a numerical day.